In the last video, I showed a sneak peek of what the pseudocode for our evaluation function could possibly look like. Let's go ahead and formalize the method definition in an evaluator.go package inside of our repository. It is going to accept any of the many node children we have defined in our AST class thus far. These could be integers, booleans, expressions, what have you. The key is that no matter what node goes in, we are going to get an object out that has been evaluated. Another important note is that this method will be recursive. If we pass in our program node, it will recurse down and begin to parse each of the statements, which will recurse even farther down to our assignments and expressions. Let's start by evaluating integers. These, and booleans, are the simplest items to evaluate. When we type 5 in our interpreter, we expect to see 5 jump right back out at us. All we want to do is take the value of our integer literal and create an integer object with it. This may seem like a hat on a hat, but for our more complex evaluations, this conversion is necessary. So add a switch statement to the evaluate function. We are going to branch depending on the type of node that we pass in. In the first case, we are going to tackle the integer literal type. Inside of the case body, just return an integer object using the node value as the body. This looks great, but it won't work because we are only passing in the top level program node of our parse tree. To fix this, let's add a couple more cases to our switch statement that will work down the branches to actually get to an integer literal. Let's start with program node. Inside of the case body, we're going to call a helper method called evaluate statements. We will write this helper method in just a moment. Next, add the case for an expression statement. In the case body, we are just going to call the evaluate function on the expression field. With this in place, the next call will be able to parse our integer literal expression. Now start writing the evaluate statements method. Here we will accept a list of statements and we return an object node. First, define the result object that we will end up returning. Next, loop over each statement and set the result variable to the output of the evaluate function called on that statement. Our result will end up just being the last statement that was called. And at this point, it is actually time to see the fruits of our labor, unless you count writing test, but those are joyless fruits. Let's go back to the console package that we wrote so long ago and make it to where we parse and evaluate what we type in. First thing to do is instantiate our parser right after we create our lexer. While we're here, you can go ahead and remove this for loop that prints out the results of our lexer. Next, call the parse program method on our parser. Next, check for errors and print them if necessary. Next, instantiate our evaluator and evaluate the program. If the object returned isn't null, we want to print it out by calling the inspect method of the returned object. And if we run this in our console, we can go ahead and play with it. With that settled, let's go back and add support for booleans in our evaluator. And surprise, this is just as easy as adding the integers, as booleans will end up evaluating to themselves. Give it a test drive in the console to make sure that we didn't screw anything up. And here we can actually make a teensy optimization. The boolean values for true and false are never going to change, and it actually doesn't make sense to instantiate them each time and return a brand new object. So we can actually pre-create the boolean objects for true and false. Go ahead and add them to our eval package above our eval function. Now it is up to just returning the correct object depending on the node value. In order to keep the switch clean, you can extract out the if statement to a method. In this case, I've called it native bool to boolean object. And to wrap up, let's add support for null. Like booleans, a null object can be created once and then referenced any time we work with a null value in our evaluator. Go ahead and pre-create the null object alongside the booleans. And with that, we're going to go ahead and wrap this one up. In the next video, we're going to continue to expand our evaluator and start taking a look at prefix expressions. See you there.